Good morning. This is Navaneethan Krishnan for AICTE PRERANA exam preparation, GATE exam preparation for that. Today I have to meet the subject of manufacturing technology. So the following questions will be discussed about the manufacturing technology, which will be important for the GATE exam. The first question is, which one of the following is a solid state joining process? So today we go to see about the joining process of the metals. So joining is the process of combining two material by various process or method. Here the welding is the process of joining two metals or materials. The various types of welding, arc welding, gas welding. So these are all the welding process for joining the two material. Here the question is, which one of the following is a solid state joining process? The various answers are gas, tungsten, arc welding. The first choice answer is gas, tungsten, arc welding. Second one is resistance spot welding. Third one is friction welding. The fourth one is submerged arc welding. So the various process of joining here, the welding is the process of joining, one of the joining process. By using the arc welding, the gas tungsten arc welding. So by using a gas as a shielding gas is gas. The joining metal, the arc welding, we need for one electrode. That electrode material is tungsten. So the gas tungsten arc welding. So another type of welding is resistance spot welding. The second one is resistance spot welding. So making a electrical current, it will be make a resistance by particular of spot. One single part you have to make it joining, that will be on by using the resistance spot welding. And another one is friction welding. So make a friction in between the two material by the due to the friction, the material will be on generated heat. Due to the heat, the two material will be joining. That will be called as on friction welding. And another one is submerged arc welding. So the welding process, the total welding material will be joining on submerged. So these four type of welding. So which one is the solid state joining process? Give me the answer for that. Tell me the answer for that. So which type of welding is solid state joining process? The correct answer is So the material will be on solid state. So you have to write it that which one of the solid state. Friction welding. Because of the gas junction arc welding, the material will be melted. And also the resistance welding, the two material joining point will be melted. In the submerged arc welding, that is also the material will be melted on due to this high temperature. In the friction, the two material will be on solid state. So the correct answer is friction welding. The next question is, while current is shut down in the welding circuit, what kind of voltage exists between the output terminal of welding? Once again, I repeated that. While current is shut down in the welding circuit, what kind of voltage exists between the output terminal of the welding machine? So we need for electrical current for we need a electrical current to produce a arc in the arc welding process. So in the type of arc welding process, we need a electrical current. If it is on the time of welding, it will be an breakdown on the electrical current shutdown. So which amount of voltage will be exist in between the outer terminal? The answer is GTAW and GTAW. Second one, answer B is open air cut voltage. The third C option C is KERF. The fourth answer is GOUGING. So this which one is correct answer? Tell me that. The open air cut voltage is the correct answer for that. The next question is the capacity of a material to be welded under the imposed fabrication condition into a specific suitably designed structure and to perform satisfactorily in the intended service is known as. Once again, repeated the question. The capacity of a material to be welded under the imposed fabrication condition into a specific suitably designed structure and to perform a satisfactorily in the intended service is known as. The answer is the answer A, weldment. Answer B is weld tab. Answer the third answer C is weldability. The fourth answer is tack weld. Tell me the which one is correct answer. The various answer is option A is weldment, option B is weld tab, option C is weldability, option D is tack weld. Here the correct answer is weldability. So the weldability of the given workpiece material is the capacity of the material under the imposed fabrication condition. Okay. The next question is, in which type of welding a gas shield, a consumable electrode is used and the welding can be done in all positions? In which type of welding a gas shield, a consumable electrode is used and the welding can be done in all positions? So the various types of welding, arc welding as well as the gas welding, and another type of welding, TAG welding, that means tungsten inert gas welding, and MEG welding, metal inert gas welding, arc welding, and submerged arc welding. So this type of welding. So which one of the welding is covered by gas shield? And also the electrode of the welding is used as consumable electrode. Tell me the answer for that. The answer is answer D, metal inert gas welding. So in the metal inert gas welding, the inert gas will be passed through the welding uh, welding portion. It will be covered. It will be making a shield around the welding portion. So that will be on metal inert gas welding, making a shield, and also it will be utilized as a consumable electrode. The metal will be consumable. The electrode will be unconsumable during the process of welding. So that is called as on gas shield welding. Okay. The next question is, in a metal arc welding process, in a metal arc welding process, metal transfer across the arc may take place by a method of material transfer where the metal transfer across the arc is in a larger drop. This is at the rate of 100 drops per second or less. What is this known as? In a metal arc welding process, metal transfer across the arc may be, once again repeated the questions. In a metal arc welding process, the metal transfer across the arc may take place by a method of material transfer where the metal transfer across the arc is in larger drops. This is at the rate of 100 drop per seconds or less than the 100 drop per seconds. So what is this known as? So the answer A is globular transfer. The answer B is spray transfer. The answer C is GMAW practice. GMAW practice. The answer D is dip transfer. So once again repeated the answer. Answer A is globular transfer. The answer B is spray transfer. The answer C is GMAW practice. Answer D is dip transfer. So tell me the answer. The correct answer is DAP transfer. The next question is, what is the type of shielding gas for gas tungsten arc welding? So it will be simply abbreviated that GTAW, used for carbon steels only called. Once again repeated the questions. What is the type of shielding gas for GTAW? That is gas tungsten arc welding used for carbon steel only called. The various types of answer is A. Argon hydrogen. The answer B is argon carbon dioxide. The answer C is argon helium. The answer D is helium. So the four type answer will be on given in here: argon hydrogen, argon carbon dioxide, argon helium, helium. So these four answer. So what is the answer for that? The student, tell me that what is the answer for that? The correct answer for this argon carbon dioxide. So in the gas tungsten arc welding, argon carbon dioxide. So this is one of the inert gas. Helium, neon, argon, krypton, xenon, radon. So these are all the gases will be called as inert gases. So one of the argon gases and argon and carbon dioxide is used as the shielding gas for gas tungsten arc welding for joining the carbon steel material. Okay. So the next question is a type of welding flows which is a result of a perfect proportion and mixture of acetylene and oxygen and is used for fusion welding of steel and cast iron. So once again I repeated that a type of welding flows which is a result of a perfect proportions and mixture of acetylene and oxygen and is used for the fusion welding of steel and cast iron. The various types of answer is carburizing flame, oxidizing flame, and oxyacetylene flame, neutral flame. So these are all the answer for the question. Answer A is carburizing flame. Option B is oxidizing flame. Option C is oxyacetylene flame. And the answer D is neutral flame. So tell me that which one of these correct answer. The correct answer is neutral flame. So because of so if it is increasing on the carburation, that means the carbon is increased, the flame, the temperature will be on maximum. If it is on oxidizing flame, oxygen content is more compared to the acetylene gas. If it is on oxyacetylene flame, both of the gases will be on 50 percentage. If it is on neutral flame, so this type of flame will be utilized for making on fusion welding. Okay. The next question is if the tearing efficiency of a riveted joint is 50 percentage, then ratio of the rivet hole diameter to the pitch of rivet is once again repeated the question. If the tearing efficiency of a riveted joint is 50 percentage, then the ratio of rivet hole diameter to the pitch of rivet is Answer A is 0.2. Answer B is 0.3. Answer C is 0.5. Answer D is 0.6. The correct answer is, tell me the answer. The correct answer is 0.50. Okay. Because of the tearing efficiency, if it is on riveted joint, the whole part of the rivet will be on 50 percentage will be on upward projection, the 50 percentage will be on downward projection. So if we had cut it tearing and the efficiency will be on up to 50 percentage, it will be on 0.5. Okay. So the correct answer is 0.50. The next question is, what is the name of the device? What is the name of the device used in arc welding circuit? What is the name of the device used to arc welding circuit for the purpose of modifying the rate of current change when the weld rod is varied rapidly? That means the welding rod which is varied rapidly varying. It will be on varying rapidly for welding circuits. So which type of device is used in the arc welding circuit? So the rate of current change will be on varying. So you have to use it for the various types of machines. So which one of the welding devices is used for making varying current? That is the question. The answer is the answer A is reactor. The first answer is reactor. The second answer is KEF. KERF. KEF type of welding circuit is used for the rate current rate change. And answer C is inductor. The answer C is inductor. So the inductor type of welding circuit is used for rate of cutting. This one, or the last answer is cone. The cone. So the cone type of arc welding circuit is used for this welding. So which one is the correct answer? Please tell me that. The correct answer is C. Inductor. Inductor type of arc welding circuit is used for using in the rate of current change is rapidly. Okay. The next question is, the next question is 2 1 millimeter thickness steel sheet are to be spot welded at a current of 5000 ampere. That means they have to weld it off two sheet. The question is the question is two 1 mm thickness two 1 mm thickness of the steel sheet are to be spot welded at a current of 5000 ampere, assuming effective resistance to be on 200 micrometer and current flow time of 0.2 seconds. The heat generated during the process will be on. So the two 1 mm thickness steel. We have two welding joining of two sheet that will be on making 1 mm thickness. So it will be making a spot welding process by using the 5000 ampere current and assuming the effective resistance to be on 200 micrometer. The current flow timing will be on 0.2 seconds. So the current flowing time is 0.2 seconds, will be on 200 micrometer resistance. So the heat generated during the process will be that. So how much amount of heat will be generated during the process? That is the question for that. So we have to welding a two sheet with having a thickness of 1 mm by using the 5000 ampere current and the resistance will be on 200 micrometer. The rate of current flowing time is on 0.2 seconds. So how much amount of heat will be generated during the process will be on? That is the question for that. The answer is, the answer A is 0.2 joule of, the answer B is that will be generated on 1 joule heat energy will be generated. The answer C is 5 joule. The answer C is 5 joule. And the last answer D is 1000 joule. So these are all the answer for the above questions. So you have to answer for, you have to choose the which one is correct answer. So now the answer is 0.2 joule, another is 1 joule, and another one is 5 joule, and also 1000 joule. So these are all the answer for that. Tell me that which one is correct answer. Answer A, answer B, answer C, or answer D. The answer is option D, 1000 joule. The option D is 1000 joule. The option D is 1000 joule. The next question is, in upcut milling, the workpiece is fed. In upcut milling, the workpiece is fed. The next question is, in upcut milling, the workpiece is fed. So during the metal removal process, the one of the metal removal process is milling. So milling is the one of the metal removal process. That is, surface of the metal will be removed by top surface by using the milling cutter. So here in the upcutting milling, how the workpiece will feed into the against the tool. So that is the question. The answer is option A, against the rotating cutter. Answer B is at an angle of 60° to the cutter. The answer C is in the direction of the cutter, and the answer is at the right angle to the cutter. So these are all the four options given for the upcut milling workpiece. How the workpiece will be feed against the tool? That is the question. So tell me that which one is correct answer. So already told that the question have against the rotating cutter. That is the answer. Option A is the correct answer for that. The work is against the rotating cutter because there is the upcut milling. Because so the top surface will be contact the surface with the tool. So the answer is against the rotating cutter. The next question is which of the following statement is correct regarding grinding of high carbon steel? The question is which of the following statement is correct regarding grinding of high carbon steel? The answer is option A. Grinding at high speed result in the reduction of chip thickness and cutting forces per grit. The answer B is aluminum oxide wheels are employed. The third answer C is the grinding wheel has to be of open structure. The grinding wheel has to be of open structure. The fourth answer is all of the above. The question is which of the following statement is correct regarding grinding of high carbon steel? Option A is grinding at a high speed result in the reduction of chip thickness and cutting forces per grid. Answer B is aluminum oxide wheels are employed. Option C is the grinding wheel has to be open structure. The fourth answer is all of the above. So the above said answers are true. That will be called as a fourth answer. The answer for that all of the above because of the grinding of high carbon steel. The above said answers will be on involved. That only the statement of all will be on exactly correct. The grinding and high speed result are reduction of the chip thickness and also the cutting forces per cut. In this cutting process, aluminum oxide wheels are will be involved, and also the grinding wheel is an open structure. So the four three answers will be on correct. The next question is in oxyacetylene gas welding, temperature at the inner cone of the flame is around. In oxyacetylene gas welding, temperature at the inner cone of the flame is around. So we have to use it as a gas welding process. The gas will be an oxygen and acetylene gas will be unutilized. So making a flame by using the oxyacetylene gas at the inner cone temperature, we have to measure the inner cone temperature. The flame is around temperature at the inner cone. The flame is around. Option A is 3500 degrees Celsius. The option B is 3200 degrees Celsius. The option C is 2900 degrees Celsius. Option D is 2550 degrees Celsius. So how much amount of temperature will be in this? In this oxyacetylene gas welding, the temperature at the inner cone of the flame is around 3200 degrees Celsius. The correct answer is 3200 degrees Celsius of temperature is on inner cone flame. So that is the correct answer. Oxyacetylene gas welding inner cone is 3200 degrees Celsius. The next question is two plates of the same metal having equal thickness are to be butt joint welding with the electrical arc. With electrical arc, when the plate thickness changes, welding is achieved by. The question is two plates of the same metal having equal thickness. The question is two plates of a same metal having equal thickness are to be butt joint welding with electrical arc. When the plate thickness changes, welding is achieved by. The following answers are given. The answer 1 is adjusting the current. The answer 2, adjusting the duration of the current. Answer C is changing the electrical size. Answer D is changing the electrode coating. Answer A is adjusting the current. Answer B is adjusting the duration of current. Answer C is changing the electrode size. Answer D is changing the electrode quantity. The exact answer is option C, changing the electrode size. Okay. Thank you for watching that. The remaining classes are on next session. Thank you.